Hi! Today we're going to learn about integration by parts. Let's say we have to compute the integral of sine x times 5x squared dx. So, how do we solve this integral? Well, this integral is basically screaming at us to use integration by parts. Let's see why. Well, we have two parts. The first part is sine of x, and the second part is 5x squared. And then we also know that the integral of one of the parts, so the integral of sine of x, the integral of one of the parts, will eventually come back to sine of x, or will eventually come back to itself, or it's some sort of repeating thing. So we know the integral of sine of x would be negative cosine of x, the integral of negative cosine of x would be negative sine of x, the integral of negative sine of x would be cosine of x, and the integral of cosine of x would be sine of x. So we can see that one part would have to be some sort of repeating thing, that when we compute the integral of, it comes back to itself. And the other part, when we take the derivative of it, it's going to become 0 eventually if we keep taking the derivative. So we have here 5x squared. The derivative would be 10x, and the next derivative would be 10. This means that x is now gone from that part of the equation. So the two parts that we must have for integration by parts is the first one, which when you take the integral of it a few times or one time, it comes back to itself eventually. Like sine of x is a good example, like right here, and e to the x power is also a good example because the integral of e to the x power is e to the x power. And then the other part that we must have is one which when we take the derivative multiple times or after one time, the x's disappear from that part, and all the variables disappear from that part, or can be cancelled out by this part. So, let's see how to do integration by parts. So, this sine of x we would have to name as dv, and this includes the dx part. So this is sine of x plus dx, I guess. And 5x squared, we're going to say, is u. So let's go over the formula for integration by parts. The formula is, we have the integral of u dv, and this is equal to uv minus the integral of v du. So let's do that. We have u is equal to 5x squared, and dv is equal to sine of x dx. So dv is always going to be the thing that we're taking the integral of, and it's going to come back to itself. And u is going to be the thing that we're going to take the derivative of, and it's slowly going to have all the x's be cancelled out or be gone. Another way to remember this is the acronym DETAIL. On this side of detail we have u, on this side we have dv. So, and the D doesn't really stand for anything, but in this acronym, the E stands for exponential, trigonometric, algebraic, inverse, and logarithmic. So, let's say that we had two parts, and one of them was a logarithmic part, a logarithmic function, and the other one was an algebraic function. Well, then we would set dv equal to the algebraic function, and the logarithmic function would be u. So whichever, if you have two, then whichever one is closer to u, we would name as u, and whichever one is closer to dv, we would set as dv. If they're the same one, then you just have to choose one and try it, and if it doesn't work, then you choose the other one, and start over. So, now that we have these, we will now do du is equal to what? Well, du would be equal to 10x, and v would be equal to negative cosine of x, 10x dx. So, if we follow this, then we get this would be equal to u times v, 5x squared, times v, negative cosine of x, so we can move the negative out front, negative 5x squared cosine of x, minus the integral of v du, negative cosine of x times du, and since we have negative here, then we can move this negative out in front of the integral and multiply it with this negative here to become plus cosine of x times 5x squared. Or sorry, 10x. Whoops. 10x. So now what do we do? We have another integral that we don't know how to compute, dx. We have another integral that we don't know how to compute. Well, once again, we can use integration by parts. This will be our dv, and this will be our u. Now, as we can see something here. If we look back at this original function, we see that we have 5x squared. So whenever we have a u that's an algebraic function like 5x squared, the number of times it takes the number of times you have to take the derivative to get rid of the x's is the number of times that you have to do integration by parts. Or you can just say that the number in the exponent is the number of times that you have to do integration by parts. So to get rid of the x's, the first time we do the differentiation we get 10x, and the second time we get 10. So we can see that the x's disappear after 2 times. So that means that we have to apply integration by parts twice. We can also see that because the exponent is 2. So when we apply integration by parts twice, we still have this part here, and now we're just applying it to this integral over here. So let's reset everything. We now have u is equal to 10x sine of x dx is now equal to cosine of x dx. That means that we now have different v's and du's. And I didn't mean, I meant dv is now equal to cosine of x dx. So du is equal to 10 dx, and v is equal to sine of x. So now this would be equal to, let's do it down here, negative 5x squared cosine of x plus, let's make a bracket, plus, now we have u times v, so 10x sine of x, so 10x sine of x minus the integral of v du, so sine of x times du, 10 dx. So here we just have an integral that we can do by ourselves without doing any sort of method for integration. So we have minus the integral of sine of x times 10 dx. So this would be equal to 10 times negative cosine of x, or negative 10 cosine of x. Now when we subtract negative 10 cosine of x, we're just adding 10 cosine of x. So we can erase this integral here and add 10 cosine of x. So the answer to this problem is negative 5x squared cosine of x plus, in brackets, 10x sine of x plus 10 cosine of x. Today we learned about integration by parts in calculus. Thank you for watching this video.